Hi, today we are going to see how to calibrate exercise 6. So for that we have to create a new project. Select the text in out folder of exercise 6 scenario and locate the text in out folder and open it. So then it select SWAT version 2012 and project architecture 64-bit. Choose the project type as Sophie 2. The project name is Sophie 2 exercise 6 and choose a project location. You can save this anywhere in your hard drive and wait for the copying to complete. So once these files are copied, we are going to the calibration inputs. First, we have to select the parameter information text file where we want to change the number of parameters and the parameter details. So as we have seen from the previous exercise, there are 13 parameters associated with stream flow, and we can add them manually from here, from add a new parameter, or we can copy them from the previous exercise. So for copying the previous exercise data, we can go to the previous exercise, go to the parameter information file, select all the parameters you want to copy and Ctrl+C copy it. And then we can go to this new file, select the 4 default parameters that are already there, delete them and paste the information copied from exercise 5. So now we can select the number of parameters as 13. The default number of simulations is 5. And we want to change that to 10. So once we have changed the number of simulations to 10, we have to go to Sophie 2 SW edit and change the ending simulation number to 10 as well. So we have to keep saving on all steps, or we can edit all the information that we want to edit and save all editing is done. Once this is done, we can proceed further. We'll check the time period for simulation. We can check it from here. The starting of the simulation is June 1st 1985 and it ends to 1997 December. The problem with SWATCUP is that it cannot calibrate a SWAT model starting from the middle of the year. So we have to calibrate it right from the beginning of the year. For that, we have to change the dates, or we can add a warm-up period of 6 months and start our calibration from the next year. So we are going to change the warm-up period here. So NY skip represents the warm-up period, and now we are going to change this from 0 to 1. That will signify 1995 as a warm-up period, and this calibration will start from 1986. Now we can go to observation, where we have to peg the reach section, and once the reach section is unlocked, we have to go to observed.rch or observed reach. We have to change the number of observed variables to 1 since we are calibrating just the outlet. In order to find out which outlet we are going to calibrate or where it is located in the project, we have to open ArcMap and find out which subbasin or outlet is located in. In order to do that, we have to select the I button and press on the empty location beside the outlet. So our outlet is located in subbasin number 17. So we are going to change the value here from 1 to 17. And we have to reformat the USGS data to the format SWATCUP accepts, and I've already done that from here. We start the date from 1996, and as we have seen in the previous exercise how to format the data, we just copy it from here and remove all our information that is there by default. We do not need them, delete it, and paste our own information. So there are 24 data points here, and so we'll change this 141 to 24 since there's a number of data points for this variable. Once this is done, we can save this. Now moving forward to extraction. So variable file underscore reach is the file where we want to select the outlet number or the location of the subbasin, location of the outlet in the subbasin. So that would be outlet 17, and save it. Now moving forward to SUFI to extract reach. The number of variables to get here is just one, which is a stream flow. And as we have seen from the previous exercise, 7 or column number 7 represents stream flow. We do not need the other one, so we're just going to delete it. In order to find the total number of reaches in the project, we again have to go back to ArcMap, go to HRU analysis reports, and final HRU distribution. So here we have the number of subbasins as 17. So we're going to change this value to 17. The number of reaches to get for the first variable, that is for streamflow calibration, is just 1, which is the 17th subbasin outlet. We do not need these two lines since there are no more variables to calibrate. So now we have to define the start and end of the simulation period. Our simulation period, this time period should not include the warm-up period. So our simulation period will start from 1996 to 1997. The time step is set as monthly by default. To save it. In order to go to the object, now next we have to go to the objective function and select observe.txt. These changes would be similar to the ones that we have made earlier in observe.reach. So the number of observed variable is 1, that is located in the stream, that is the outlet number 17. The objective function for this calibration is Nash Sutcliffe. We can select any other objective function as desired, but for this class we'll stick to just Nash Sutcliffe, which is in number 5. The minimum value for the objective function, or the threshold, is set to 0.5, and now we are going to change the outlet number, that is 17. The default data can be removed and replaced with our own data that we obtained after reformatting the USGS data, and change the number of total points to 24 since we have just 24 data points. Save. The variable file name, we have to again make some changes here like the ones that we've changed earlier, and define outlet number 17 here. Save it and close all. Okay, and if you have forgotten to save anything else, you can save it from here. You save all changes. So now we can start a calibration process. We'll click calibrate and execute all. Are you sure? Yes. Oh, okay. So this is done now. And we can save the iteration here, and now we can look into the calibration outputs. Go to summary stats, and here is our result. We have 0.77 Nash Sutcliffe and 0.79 R square, and we can go to check the 95 PPU plot. That is all. Thank you.